if you want to do everything and follow along with me, go ahead and download this notebook or find this notebook in the course repository so that you can run it with me. But at the end, I will also give you some assignments to play around with this notebook a little bit more. So if you want to play around, do things by yourself, just wait a little bit and finish this exercise, watching this exercise, and then you can go ahead and change some of the settings and observe what happens. So I am normalizing my input. Just going to take a look at the one of the examples to see if everything went well, if I am doing what I think I was doing. It looks correct. Everything's between 0 and 1. All right, I will set my first network. Just look at the summary of what I have. So I have the dense layers, I have the flattened layer. It looks all correct. And this is a number of parameters we have. We do not have any non-trainable parameters, which is the case, as I expected. Just looking at some summaries. All right, so we can compile this model and then fit it. And I'm going to fit it at first for 30 epochs, so it's going to take a couple of minutes. Now the network is trained. Let's go and check out what it looks like. My accuracy went all the way to 0.7, which is pretty good. But validation accuracy didn't seem to have followed it quite well. So let's look at the graph to see how everything went. All right, so as you can see, this blue line is normal loss, a training loss, and it keeps getting lower, and the accuracy keeps getting higher. But what I'm seeing is actually this model starts overfitting after a while because my validation loss kind of gets lower a little bit. I'm just looking at the general trend of this zigzaggy graph. But after a while, it stays like flat. And then here you even see some sort of an upward trend again. And also the validation accuracy, it gets a bit higher, but then it kind of starts following the same line. It doesn't really get any higher anymore. So this makes me think that this model is overfitting, and if I train it even more, it's going to keep overfitting even more. So what we want to do then is to introduce some regularization. So let's do that and see how that's going to help us. The regularization technique I'm going to use is dropout regularization, but specifically I'm using a specific type of dropout regularization, which is alpha dropout regularization. The reason we're using alpha dropout regularization is because this is a self-normalizing layer. That means we don't have to have any extra normalization steps in between the layers, thanks to the cellular activation function. But that's why we need also the dropout layer to the dropout action in between the layers to normalize or input and output normalized values. So that's why we're using alpha dropout, because it normalizes its outputs once it deals with all the inputs. All right, so I will add a dropout layer in here. Well, actually everywhere, not just in there. In between all the layers, I will have a dropout layer. I decided to use dropout rate of 0.1, but it's going to be one of your assignments to also change this dropout rate and see how it affects. Because if you remember, or affects the performance, because if you remember, if we use too little of a dropout rate or a regularization alpha, then you're not going to regularize enough and your model is going to overfit even though you're using regularization. But if you make your dropout rate or any other regularization parameter too high, if you penalize too high, then your model will likely underfit, and we don't want that. So let's try with 0.1. I am reinitializing the network. So that's going to reset everything, and once I train, it's going to train from scratch again. One note here I want to show you is that I created this little chart that you can use. So I am keeping track of everything that I'm doing right now in this little sheet. And in your assignments, I'm going to ask you to try 4 different new combinations of these hyperparameters and note down the training, validation, and test accuracy also. So this is what I did at first. I used a static learning rate, a batch size of 32. We will talk about this in a second. I trained it for 30 epochs, and this is what I got, right? And now I am introducing a dropout rate, and we're going to see how that's going to perform. Let's see. the training is done. So let's see what happened this time. I will just recreate this graph again. All right, so this actually looks quite good because as you see, the blue line and the orange line, which belongs to the training values, the loss and accuracy, they are following a pattern. The loss is getting lower, the accuracy is getting higher, and the validation loss and accuracy is following it quite closely. So that's good. That means that we're not overfitting, but it looks like the training is not done yet. So basically, by running it for only 30 epochs, I am kind of doing early stopping, but I don't want to do that. So I am going to train this even longer to see how it's going to learn even further. But before that, I want to calculate the performance on a test set. Okay, it's 0.4. It's not so bad. In the previous version, when we didn't use regularization, we were able to capture a test accuracy of 0.5. So once we introduced regularization, our performance lowered a little bit, but maybe this is something we can fix by training the network a little bit more. So I'm going to train it for 30 more epochs. We're done. Once again, let's check the graph and the test performance. I'll quickly run these. The test performance went from 0.40 to 0.44, which is quite good. We're catching up with the performance that we had before. But it looked like running it for a little bit longer just, got me a bit more of a tiny bit more of a gain in terms of accuracy, and we kept lowering the loss, so it's good. Maybe if I keep running this for a lot more epochs, we will actually get to a nice point. But one other thing that I want to try with this network is to use learning rate scheduling and see if that will help me converge to a better or capture a better performance with this network.